Hey guys, this is the second part of this video, so I'd probably watch that one first. Or not. I'll just recap it here. You should go watch the other one though. Last time I designed a whole bunch of logic gates out of component parts, i.e. transistors and diodes, and got one of them, an XOR gate, onto some custom circuit boards by pcbway, who we'll talk about soon. After that is where our story takes place. See, the goal of this video is to create a full adder with these only component logic gates. A full adder is a circuit that can effectively compute 0 plus 0 plus 0, 1 plus 1 plus 1, and anything in between. However, we need more than just an XOR gate to do addition. Looking at a diagram, you can see we'll need one more XOR gate, two AND gates, and an OR gate. So, let's do it. I already designed all of the circuits in the last video, but I hadn't designed the AND gate or the OR gate from manufacture yet. For this, I used Autodesk Eagle, which I'm pretty sure is out of service and has been replaced by Fusion 360. Alright guys, this is Eagle. This is a program I used to design the files. There is one quirk on it though that I've had every time I've installed it. If you go under, you have to go under the Eagle files. Normally, this doesn't have the .back extension. You have to add that yourself. But once you do, Eagle boots up fine. What you do, you can just go up here, make a new project, call it whatever. Then you make a new schematic. This is actually what you design your board in. There are a few tools here. Net. This is basically the wiring tool. Add part. This is a huge library of parts, but a bunch more are also available online. I'm gonna be completely honest. I don't know what any of these things on the right mean. I'm not gonna pretend I do. Yeah, I think this is just a 5. This is the type of resistor I'm using, I believe. Yeah. If we hit OK here, then you can see we can place these down wherever. Usually I have the SparkFun library installed, and I just use the stuff from that. Let me see if I can find it. Yes, okay. Use. There we go. Much better. Okay. SparkFun power symbols. There we go. Coolio. Okay, we have our schematic, right? We click this button, and it'll automatically generate a board. Now you can see all of these are here in a new window. You can move these around however you like. And you have to do some complicated stuff to actually get everything to work, but you can see that this sure is kind of what the circuits look like. And yeah, that's Eagle for you. Okay, we got the AND gates. You might be wondering, what about the OR gates? Let's talk about our sponsor. pcbway is a company that provides many services. Their work has always been good to me, and anytime there was an issue, it was either my soldering or my circuit design skills that ended up being subpar. The boards are also cheap and easy to order, only $5 for 10 far more complex circuit boards than what I'm designing today. They also do fabrication, CNC, and 3D printing work, which I bet is just as good as what they do with PCBs. So check them out over on pcbway.com. With my fat bags of money safely set aside in a comically large vault, let's get to soldering. Yeah, I didn't record myself doing it. After seeing last time that soldering footage was about as interesting as eating nails, I chose not to. Just for you guys, I will demonstrate a single solder job. Hey guys, so I have this PCB that I have spare and this resistor, and I have a soldering iron, and I'm gonna show you guys what I did. Okay, we take that, we put that, I'm trying to do this one-handed, this is gonna be terrible. Please don't do it like this. Hey, this is how you burn, oh my god. How do I even do this? Right. I'm gonna take my soldering iron. Did that just land on my pants? I think that landed on my pants. I'm just trying to... Sorry, I don't have it. I'm just trying to get a little bit of solder. If we just get it down there, then... Yep. Usually this would be a lot neater, but I'm literally doing this with my hand. That's soldering. Let's move on to assembly. This was the most troubleshooty part of the project. Let's take a peek. I sure really hope this works this time. Eek. Oh, yes. Well, I don't know what's going on with this, but... Yeah, look, you might have caught it, but right now, this one should be on. Okay, let me illustrate it better. Okay. You can see, this is carry. No, this one's carry and this one's out. Which basically means this one is worth 1 and this one is worth 2. So, 0 plus 0 plus 0. 0. 0 plus 1 plus 0 plus 0 is 1. But 1 plus 1 plus 0 shouldn't equal 0. But if I do 3 again, then 1. Which basically means this AND is not ANDing when it should. What beautiful wiring, am I right? At one point, I decided to test if the rat's nest of jumper wires could hold up my phone. And guess what? It could! There was a major issue with my plan though. See, my idea for the OR gate was initially to use a miniature breadboard, a few jumper wires, and an LED. Let's move over to me in real time for this bit. Okay, guys, I have come up with the world's worst solution. It turns out the problem was basically... Shut up, Edge. I had the wiring like this. These are the two AND gates. If we link them both, this is how I was wiring it up before. You can see that if this top AND gate is on, the AND gates aren't working. That's fine, doesn't matter for our demonstration. Basically, I think it might have something to do with the boxes. The electricity isn't flowing into the LED, it's flowing into the path of least resistance, which is, if we slow down the current speed, you can see down this wire and down to this linkage through to ground. So, I have come up with the world's laziest solution. What if we took this and then put another one over here? That way, there's no possible way anything could go wrong as long as you pretend these are the same, because they physically can't flow into each other, as there is no physical connection. You know, unless I way amped up the voltage. See? Works like a charm. As long as you pretend these two LEDs are the exact same LED, then it works perfectly. I could use diodes and a voltage amplifier, or, you know, make a better OR gate and use a voltage amplifier, but I don't feel like making another component for this, so let's just pretend it works, okay? Okay. Get wire. Okay, right now, these are the two input switches, and this is the carry switch, which is basically, we can add a maximum of 1 plus 1 plus 1. If I get this multimeter out the way, and I organize everything how it probably should be, this is the carry. I've said this a million times before. This is carry, and this is output. So this is basically worth 2, and this is worth 1. Not both of these. Both of these won't turn on at the same time, probably. But just pretend it's one LED. And we can do that if we just go at this angle. Good enough. Okay, so now I have just 1. Brilliant. It's 2. Okay. And now it's 3. Yes! Oh my god. It's working. It's finally working. If I tested all 8 combinations, I can knock that out pretty quickly. Okay, this is a combination. 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 And this is a combination. It works perfectly. Ignore this one that's flashing. It's part of the mechanism. Yes, it's working. Well, oh my god, I'm so glad this finally works. Well, it took a lot of work to get here, but full adder made completely out of component parts. Well, that was fun. I'd like to thank pcbway and also say sorry to them because it's been months again, hasn't it been? Well, that's the end of the video. Probably. Hey guys. Oh man, has it been a while since we've posted an act? Well, I mean, as I'm finishing this, Ari literally posted his Logic Gates video a few hours ago. So enjoy the new content, I guess.